In this tutorial I will show how to edit the scale in the wind simulation function in Vasari and give some other tips and tricks for simulating wind. The first tip is that you should always have a bottom plate for your context, and this bottom plate should have some thickness of maybe 500 millimeters or so. It should not be too thick, then the wind will see it as a windbreaker and then it will create not accurate wind results. First you need to go to the analysis part of Vasari, starting up the wind tunnel. I typically start maximizing the window so I can better see what's going on regarding the simulation. As default, as you can see here in the viewport, it extends the analysis grid. If we go down to model display, we can also see the analysis grid by clicking this on, and by right clicking you can change the view angle. And here we actually can see the 3D analysis box. In this box the simulation will take place. So as default it takes half of the width and height of the model on each side all the way around. For the height, typically it's too high. So the height should be something like doubling the height of the model you have, and then it will create accurate results. As default it sets also the analysis grid size, but the problem with this typical is that you cannot get down to the level of the head of a person, because the cells, these ones, are too big, so it cannot be pulled down so you get the right height of the simulation. So you can change that by go to analysis grid settings. Typical I use something like between 5 and 8, and that gives also more accurate results for the simulation, but it takes a little bit more time to simulate. So I will try it with 7 in this case, and typically it also creates maybe little too high volume around the building. So I also pull that down, in this case 150, I think it should be okay, to have not too many analysis cells. And now we can see it takes a little bit longer time to calculate the wind pattern. And now I have a better opportunity to control the height of the analysis grid. After a while the simulation will stabilize, so you will have accurate wind pattern. If you want to compare different proposals in same scale, or else it's difficult to read the output visually if it's not the same color scale. And of course it should have the same wind speed, the same height and angle before we can compare it. If you go to data display and stop the simulation, now we can see it's stopped, it's not moving or simulating. Here we can type in on the minimum and maximum values, so we can over control the scale, and we can see now it's fitting the colors from the simulation to the scale. And of course I can change this if I want to look at specific range where we have wind speed between 5 and 10 meters per second. We can change that to see where do we have the critical spots. We can also change the colors. It could be a grayscale. Typical I use this one because I'm using blue, red and yellow for solar radiation typically. So to have some kind of difference between the solar radiation and the wind simulation, I use different colors. Further, I usually also turn off the ground plane grid, because unfortunately we only can take this as a screen print. We cannot save it as an image file. So I want to have it clean as possible, so I turn off the ground plane grid by going to model display, and we can turn that off. We can also turn off the windrows and the totally compass by going to toggle this off. And in this way we can tweak the output so we get the right result that we want. I typically also click this off, use advanced lighting to have it more strong colors when we're exporting it. Another good tip is to copy this dialog box so you have the same size of the grid. In this way it's easier to compare the result, because as I also said in the beginning, if you don't have the same size of the grid, then it will not create the same wind speed inside this box, so to say. Take a print of this so you can type in the same sizes of the grid. To show the difference between the voxel size, the analysis cell size. Here is the first one. I used 8 in the voxel size and 4. And as we can see here, it's of course getting more detailed, more accurate by having smaller voxel size. But it takes a longer time, and sometimes you don't have time enough for waiting on the results. But maybe on the final simulation you want to send to your client or in the scheme, you could use a smaller voxel size to get a more accurate and more fine result. But for early stage, higher voxel size is okay, because it's only an assumption of how the wind could be on this side.